Hi everybody, this is Jason, the Science Outreach Manager and Life Science Educator here at the Children's Museum Houston. I am inside the Inventors Workshop to show you how to make a parachute, which is being brought to you by Chevron and is part of our National Engineering Wonder Week. Before I show you how to make that parachute, which looks like this, and they can look differently than this as well, I want to tell you a little about aerodynamics, how things fly. The reason why a glider or an airplane or a balloon flies is because four forces are in balance. Those four forces are lift, they are drag, they are gravity, and they are thrust. Lift is the ability for a flying machine to get away from the gravity coming from the center of the earth, the ground essentially, and fly through the air. It is able to do this because of the Bernoulli's principle, which states that the faster a fluid, and a fluid can be a liquid or a gas, in this case, flying machines, the atmosphere, the faster a fluid is moving, the less pressure it's going to have. Conversely, the slower a fluid is moving, the more pressure it's going to have. So when we make airfoils, which are wings, we design them in a way that there will be faster air going on the top of the wing and slower air going underneath the wing so that the pressure is greater underneath and lifts the flying machine off the ground. It's very simple to understand right there. Now, drag is sort of the opposite of lift, but not, in a way it's not. Basically, drag is air resistance, it's slowing something down. So yes, drag would cause something that's in the air to start to gently go back to the ground, but what drag is really opposing is thrust, the forward movement of a flying machine. Now, thrust can be created with wind, but it can also be created with propellers and combustible engines. So depending on what kind of thrust you are using, drag will not be in play until it needs to be in play, if you will. Now, finally, you have gravity. Think about gravity. You have two masses that are of different sizes. The smaller amount of mass will be attracted to the center of the larger amount of mass. Think about this, the Earth, the biggest object we know of. Everything on the Earth is being pulled towards the center of the Earth. That's the gravitational force of the Earth. Think about this, the sun is the biggest object in the solar system. All the planets are being flung around the sun in their orbits because they're all being pulled towards the center of the sun. It just depends on where they are as their particular orbit is seen. So you can see gravity in action with flying machines, but also just in the natural world. So when you have all those things in balance, that's when something flies. Now, when it comes to a parachute, you're actually going to focus more on the drag. I have one time in my life gone skydiving. I jumped out of an airplane, deployed a parachute, and thankfully drifted slowly to the ground. But here's what happened. When you deploy the parachute, and they look kind of like this. They can be many different shapes, but usually it's sort of looking like an airfoil. What happens is you initially are lifted up. You actually have a high amount of fast-moving air on the top of the parachute and slow moving on the bottom of the parachute, so it lifts you a little bit. So you kind of appear to jump like this. It's very fast. After that though, the air underneath the parachute starts to move faster and the air above the parachute starts to move slower. It's called air resistance, so you are being pushed gently to the ground. What's cool though about a parachute is that you can control it when you're moving along. As you go to the ground, you can sort of move forward, you can sort of move to your left and to your right as you sort of drift down. So it's a good thing to have drag in that case because you don't fall very quickly and hurt yourself. You fall very gently and you're fine when you get to the ground. So we're going to make parachutes, and I'm going to show you a particular way of making a parachute, but you can do yours differently using different materials. So the materials I'm going to use, you might have, you might not. Don't worry if you don't have them, just substitute it for something else. As long as you sort of follow what I'm doing right here, you'll be fine. So I am using a substance called Mylar to make my parachute. You can find Mylar at like a sporting goods store. Lots of times they're used as emergency blankets when suddenly the temperature gets really, really cold and you're not prepared for that. You can wrap a Mylar blanket around you and get very, very warm. The reason I used to like to use Mylar, it's lightweight, but it cuts very easily and you can make the shapes you need quite simply, okay? You're also gonna need some stickers, these little circle stickers. Always have some scissors, a ruler, a pencil on hand, and you're gonna need some string, okay? Now, I use templates to make these shapes. This is a rectangular shape. This one here is an octagon shape. I have a circle shape and I have a triangle shape. Now, you don't have to make these shapes yourselves. We have the shapes on our website. This project's on our website where you can read step by step how to make a parachute and you can know how a parachute works. So all you have to do is you can go on our website, print these out. I would print them on cardstock, it's more durable. Print these out and then go ahead and use them. If you can't do that, I would say just go ahead and draw some shapes out. And use a ruler, like I said, always have a ruler handy. Use your ruler to make sure the sides are even. So like if you're using the rectangle one, which is this one, you want this side to be even with this side and that side to be even with that side. Do as best you can. Once you have these printed out or once you've created them yourselves, and it's good to make different shaped ones because they do different things when you deploy them, when you release them and let them go. You just want to go ahead and cut them out. It's real simple. You just cut these out. And then you lay out a large piece of Mylar or plastic or whatever you're using, tape it on, and you cut around it, and then you get these right here, okay? Real simple. You just go ahead and cut around it. I would suggest though that you put tape on the back so you can hold it down on the Mylar. And you see where I have these kind of black lines right here? That's really important to be able to see because then you can cut on those black lines when you're cutting out your Mylar or your plastic or whatever. Once you have that done, you're gonna grab your string and you're gonna go ahead and measure it out. Now I don't have with me right now a big measuring tape or a yardstick or anything like that. So I'm gonna kind of estimate. This table is probably 5 feet long. I'm gonna go about halfway to the table, which is about here, which would be about 30 inches, and I'm gonna just go ahead and cut it. Now, instead of trying to measure again, I'm just gonna get the string out, put it on one end of it, go to the other end here, and I'll just cut it again. Okay, and then you can just take your two strings, even them out on one side, and oh look, I got it pretty even. So I'm just basically gonna take this side over here and just cut a little off so it's pretty fairly even, more so than before. And once you have done that, you're gonna take your Mylar piece, and you can see I already made two of my strings attached to this parachute right here using these circles, these little circle stickers right here. I'm gonna do it again with a new piece of string on the other end of the triangle. So I'm just gonna put that down right there and go ahead and grab a different color sticker and I'm gonna stick it on. So then you have this, like this, okay? Now you noticed I've also tied one of the strings to this bunch of washers right here. Basically, you would tie all three of them to the bunch of washers. So I'm just gonna show you how to do that with this other piece right here. I'm just gonna thread it through. Go ahead and tie it off. And then obviously do a double knot so it doesn't slip off. The part that will probably slip off more than anything, it'll slip off of these circles every now and again. Just get more circles and put it back on and you'll be fine, okay? When I pulled off my rectangle one here, one of them slipped off the yellow one here. Actually, it keeps slipping off the yellow one, so I might re-secure it as much as I can. And that's another big thing about making is that when you're making, every once in a while, you've got to go ahead and try again or fix it so that it's better. So I'm going to try to fix this so it's better this time by doing two. Okay, and then you have yourself a completed parachute. Now, one thing that you want to be aware of when you go ahead and test your parachute, you can just sort of toss it up in the air and let it fall, but it doesn't give it enough time to deploy and really show you that air resistance. What you want to do is you want to get somewhere high, second story of your house, the second story of your school if you have that. On top of the play area, you know, you have those jungle gyms, get on top of the jungle gym. Just somewhere high enough that even if you have to throw it a little bit, it has time to deploy and float gently to the ground. Also, the washers are really important because they add weight to the parachute. And you may not believe this, but you weigh a lot more than your parachute. Like you hold your parachute on your back, you weigh a lot more of it. It's just the shape, it's the design of the parachute that allows for the air resistance. Let's go ahead outside right now and I'll show you how my parachute works. All right, we are outside right now with the parachute. I'm using my sort of rectangular parachute. And in a moment, I'm going to go up on the roof over there to let it go. Now, here's what I want you to be aware of. If anything goes wrong with the parachute, that's okay. This is not a real person. This is a washer. That's the whole idea of engineering. If something goes wrong, you think about it and you fix it. So if something goes wrong, like a string falls off or just plummets to the ground or anything like that, don't worry about it. Just go ahead and fix it. We're gonna throw it once and see what happens, okay? Now my friend John, he's gonna come out in a moment. He's gonna run and try to catch it so it doesn't get caught in a tree or anything like that. So give me a moment. I'm gonna go up onto the roof and then we're gonna let this thing fly. All right, so you saw it coming down. It sort of opened up and then it got a little bit inward again because one of the strings broke and the wind was blowing. So it's not gonna work exactly like a parachute, but you get the idea of that drag. It slowed it down. If this was like a rock, it would have hit the ground instantly, but this was able to come kind of glide down. Now, my string broke, so I gotta figure out a way for my next launch how to fix that. I've already kind of tried to fix it. I put the string back on, but that's the engineering goal again, to get all the problems solved. That was really cool, wasn't it? Now, my next step would be to test all my different parachutes. I have my circular shaped parachute. I have my octagon shaped parachute. The octagon shape is really one of the more popular shapes of a parachute, almost like that shape. I have my triangle one. So what I would do is I would go and test them all out, see which one works the best, which one doesn't work very well at all, things like that. But because I'm just testing out shape at this point, I would have to do it from the same exact height. You only want to change one variable. In this case, the variable I'm changing is the shape. Now, I really am more interested in seeing your parachutes. So if you have Instagram or Facebook or Twitter, go ahead and take a picture of the parachute you made and post it. We'd love to see it, especially if it's completely different than the one I showed you how to make and you made one of a totally new design and it works better than mine, because then I'm gonna steal it and I'm gonna start teaching that one instead. So I'll give you credit though. So if you have that ability to do so, do it, please. I wanna see your parachutes. Also, if you are on YouTube, please hit the subscribe button. We really want to show you everything we have to offer. We have our Top Tunes band. We have our Mr. Oh Wow moments. We have more science videos and we have story times that are really great. And we'd love you to see all the content we have available. With that, I am going to say my farewell now. I want to thank Chevron once again for allowing me to do this project. I hope you are doing well. I hope to see you soon. This is Jason saying bye for now.